Hello and welcome to Physics with Amol sir. So this video is for class 12 and today we are going to start with a new chapter, that is chapter number 3, current electricity. Okay. Now as such the concept is not very new for you. Okay, even in 10th standard we had seen the concept of current electricity. But of course in this particular chapter many new things we are going to see, and some of the things that you have already studied in 10th you are again going to face them here. Okay, so let's begin. So the first two chapters we basically focused on electrostatics, that is when charges are at rest. Okay, but when we talk about current electricity, we know current electricity is when charges are in motion. That is why we give the name of current. Okay, so that is basically the idea behind current electricity. Now some of the topics that you have already seen in 10th, I am not going to repeat the entire thing. Okay, so let us talk about the basics of current electricity. So we know there are some materials which are called as good conductors of electricity and some which are poor conductors. A good conductor of electricity contains something called as free electrons. Okay, I am sure you remember this. We had seen this in 10th as well. Okay, so if this is a good conductor, it contains a large number of free electrons. Okay, free electrons, we call them as free electrons because they are not really bound to the atom. Okay, they are free to move inside that particular material. So any good conductor contains a large number of these free electrons. Okay, so any metallic conductor, anything that you are seeing in front of you, that is the conductor. Okay, it will have these electrons. But if you touch this material, you do not feel a shock. Okay, reason is that all these electrons are having a random motion. Okay, they are moving all over the place. So therefore, they do not form an electric current and we do not get an electric shock. So if you hold a metallic rod in your hand, you don't feel a shock. Okay, it is having electrons, it is having free electrons which are moving, but they do not constitute an electric current because they are having randomized motions. Okay, that much I am sure you remember. Then how do I make sure that all the electrons will create some kind of current? I hope you remember, we have to give a potential difference. Okay, so if we give some potential difference, here if we give positive and here if we give negative, the electrons being negatively charged will start moving towards the positive, right? So all these electrons which were earlier having randomized motions will now move in the same direction, and that is what causes the electric current. Okay, again as I said, these were the topics we had discussed in class 10. So whenever we say electric current, basically we are talking about the motion of these free electrons through the conductor. A poor conductor contains a very small number of free electrons or negligible number of free electrons. Therefore materials are poor conductors, but good conductors will contain a large number of these free electrons. Okay, that is why they get an electric current to flow through them. Correct. Now let us see some basic definitions. First definition is for electric current. Okay, so electric current I we define as amount of charge flowing through a cross section per unit time. Okay, I am sure you remember this formula that we had in 10th standard. I we wrote as Q upon T. Okay, Q denotes the amount of charge and T denotes the time. So I is Q by T, that is electric current. Okay, current we measure in the SI unit of amperes. Okay, so SI unit of current is ampere denoted by capital A. SI unit of charge is coulombs and time is second. Okay, so that is how we define electric current. Next we will talk about the most important law, that is the Ohm's law. I am sure you remember, even in 10th class we have discussed this, that whenever we are studying about current electricity, the Ohm's law is a very fundamental law. Okay, so Ohm's law says that for a given conductor, okay, if the conditions, that is the physical conditions remain the same, okay, the potential difference is directly proportional to the electric current. Okay, so V is directly proportional to I, therefore we can say V is equal to IR, where R is called as the resistance of that conductor. Okay, and we also remember resistance depends on the length and area of cross section. This concept again I will repeat, we had covered in 10th standard, so I am not going too deep into it. If you feel that this needs to be explained, please let me know. Okay, so this is the Ohm's law. V is proportional to I, therefore V is equal to IR. Now let us talk about resistance. So resistance, we say it is the property of a conductor to to oppose the flow of electric current. Okay, so that property due to which a conductor will oppose the flow of current. Okay, so whenever electrons are flowing through a conductor, they face opposition. Opposition because there are other atoms present in that conductor which do not allow them to pass. Okay, that is why they are facing some opposition, and that property we call as the resistance. Now, there are two factors on which the resistance depends upon, assuming that the material and temperature is constant. Okay, so for a given material, if the material is same and the temperature is constant, then the resistance of that particular conductor will depend upon its length and its area of cross section. Okay, then we know that resistance is directly proportional to the length. Okay, and inversely proportional to the area of cross section. What it means that if the length of a conductor is increased, its resistance will increase. If the area of a conductor is increased, its resistance will decrease. Okay, again this relation also I am hoping that you are remembering. So R we say is directly proportional to L by A. Then to remove the proportionality we add a constant. So we get R is equal to rho L by A. This constant rho is called as the resistivity of the conductor. Okay, so rho we call as resistivity, or one more name for it is called as specific resistance. Okay, so what is rho? We can write rho as rho is equal to RA by L. So if I am having 1 meter of length and 1 meter square of area, so unit length and unit area, then I will get rho is equal to R. So that is how we define the concept of resistivity. We can say that the resistance of a conductor having unit length and unit area of cross section is called as the resistivity of that material. Okay, so that is the concept of resistivity. Okay, so these two things look very similar, resistance and resistivity. Okay, see, resistance is property to oppose the flow of current. So a particular conductor can have some amount of resistance, 5 ohms, 10 ohms, 20 ohms. Okay, but resistivity is an inherent property of the material. So the resistance of a conductor can change. How it will change? You increase the length, the resistance will change. You increase the area of cross section, the resistance will decrease. But resistivity is a constant property for that material at a given temperature. Okay, that is the concept of resistivity. We need resistivity so that we are able to classify the materials. So if a particular material has got low resistivity, then we know that it is a very good conductor of electricity. Okay, so again, as I stated before, I am not going too deep into these concepts because in 10th standard we had already covered them. Okay, one thing I forgot, resistivity. The SI unit of resistivity is ohm meter. Okay, so SI unit of resistivity is ohm meter. SI unit of resistance is simply ohms. Okay, then you will find all these concepts, all these definitions in the class notes that I will be giving you. So go through them once again. If there are some things that you want to be explained once again, I'll make sure that I will explain it to you. Okay, so that's all for this video. Thank you.